changed the question. It was cosine x minus sine of x equals 1, but I made it be minus 1. And again, so we started off by looking and seeing where's our solution. So, right, this solution is going to occur, and then we have this one. We could start here, but we're not. We're going to use this one, and then we're starting. So you can actually, this is the full, oh, this is tricky because our full cycles are weird, but this is going to be where we're at 0 and we're at 2 pi. So this is one full, right? So we're looking at this solution, and then when this solution repeats, we're here, and we're looking at this solution, and when this solution repeats, we're a little bit off of the screen. Okay, so let's look at what happens algebraically, and then we'll see what we get, and we'll compare it to what happens. So this question has an interesting strategy. It says, again, we can't really factor that, so what is we can't change it to anything because sine and cosine are already at the kind of most basic form we can get, but we have this cosine squared thing, so let's just see what happens. So it says, let's square both sides. And if you remember, when we were working with radical functions, squaring both sides was something that created extra solutions. So let's hold that in our mind till the end. So cosine squared minus sine squared, or sorry, cosine theta minus sine theta squared is 2 of those. And so I multiplied that out. And then I just took the cosine squared plus the sine squared and rewrote it out here to get 1. And then I have minus 2 cosine theta times sine of theta equals 1. I move the 1 over, divided by -2. So I end up with just cosine theta sine theta equals 0, which means the cosine equals 0 or the sine equals 0. Right? So, and I'm looking at all the places. Oh, here's 0 cosine. Here's 0 sine, right? And that's going to repeat, right? And here's 0 cosine, and that's going to repeat. And so that's where all of these solutions came from, right? Pi over 2, pi, 3 pi over 2, and 0. I should have started at 0. So you first ask, where did all they come from? They came from solving both of these parts for 0. But we have, because we squared it, right? We have to look for extraneous solutions. And if we graph both of these, we can see, well, they are overlapping, right? We do get, sorry, this one is the repeat of this. We get some overlap, but then we get these extras. So the graph is going to help us see where the solutions are and where the squaring created those extraneous solutions.